Welcome back to our data science series. Today we are diving into an exciting topic which is deep learning. So you have probably heard the buzzword like neural networks, TensorFlow and PyTorch. But what do they actually mean and how do they work? So by the end of this video you will understand the basics of neural networks, the role of deep learning in artificial intelligence, and the last one is how to get started with popular frameworks like TensorFlow and PyTorch. And of course, we will write some code to bring these concepts to life. So let's ready. Okay, so the question is what is deep learning? So, what exactly is deep learning? At its core, it's a subset of machine learning that uses neural networks to model and understand complex patterns. Think of it like teaching a computer to recognize images, process speech, or even generate human like text. So, this is the difference between the traditional machine learning and deep learning. In the machine learning, we provide the input and feature extraction by humans and then classify, and the last one is output. But in the deep learning we will provide only input. So in the middle layer, feature extraction and classification done by itself. There is a minimal interaction with humans, and the last one is output. So neural networks are at the heart of learnings, mimicking the way the human brain process information. So let's break this step by step. A neural network consists of layers of nodes, which is also known as neurons. So these layers are divided into further three types. The first one is input layer, the second one is hidden layer, and the last one is output layer. So in input layer where the data enters the network, as you can see in the diagram. In the hidden layer where the real magic happens, feature are extracted and learned. And the last one is output layer where predictions are made. So this is the this one is the diagram of a neural network. Okay, so each connection between nodes has a weight that determines the importance of a given feature. Through a process called training, the network learns by adjusting these weights. Okay, now that we understand the theory, let's set up our environment using TensorFlow, which is a powerful deep learning library. If in your environment TensorFlow is not installed, so uncomment this and run the cell. Okay, so I already installed. Okay, so first we import our libraries. The first one is import TensorFlow as TF. The second one is from TensorFlow import Keras, and the third one is import NumPy as NP. Okay, now creating a simple neural network model. Okay, declare a variable model equal to Keras dot sequential. So don't worry about the code, I will explain it later. Keras dot layers dot dense. Now 128 activation equal to relu. Okay, input shape equal to 784. keras dot layers dot dense 10 activation soft max. Okay, now after this compile the model. So model dot compile optimizer equal to Adam loss sparse categorical cross entropy and matrix equal to accuracy. Okay, now summary of the model. Model dot summary. Now run the code, select the environment. Okay, on the line 9, Kira's layer length 128. Now it will take some time because for the first time it will run on my PC. Okay, so here you can see the summary of the model. So this is a simple model is ready to classify data and you can see how few lines of code were needed. So thanks to TensorFlow. Okay, now I will explain the code. So first we importing libraries. The first one is the TensorFlow. So the core library for building and training deep learning model. Now the second one is Keras, a high level API that simplifies model building in TensorFlow. And the third one, as you know, used for the handling data arrays. Okay, so here we use Keras sequential. At this step, we will building the neural network model. So Keras dot sequential helps to take layers linearly to perform a neural network. Now Keras dot layers dot dense. Here we use 128 and activation equal to relu. So it's create a fully connected layer with 128 neurons and the relu activation function. And the input shape is 784. So the input layer expects 84 features. For example, flattened images of size 28 into 28. Okay, now the next one is dense 10 and activation method is softmax. So the output layers with 10 neurons for classification into 10 classes using the softmax function. Now compile the model. Here we will use a optimizer equal to Adam. So Adam adjust weights to minimize the loss during training. And the second argument is loss equal to sparse categorical cross entropy. So it measures the difference between predicted and actual label for multi-class classification. And the last one is the matrix. It will track the accuracy of predictions during training. And the last one, print the summary of the model. Okay, now the next framework is PyTorch, which is another popular framework. So, loved for its flexibility and dynamic computation graph. So, let's build a similar simple neural network with PyTorch. So, if you use this model for the first time, then uncomment this line and run the cell. Okay, first we import our libraries, import torch, and the second one is import torch.nn as nn. Okay, the third one is import torch.optim as optim. Okay, now define a simple neural network. So for this we make a class simple nn. Now pass the argument dot nn dot module. Okay, here we define a function in a initial self. Okay, then we use super simple nn self dot function. Okay, now self dot fc1 equal to nn dot linear 784 128. Now self dot fc2 equal to nn dot linear 128 comma 10. Okay, now the next function is forward self x. So x equal to torch dot relu self dot fc1 x, and the second one is x equal to torch dot soft max self dot fc x dimension equal to 1 and return x. Okay, now after this initialize the model, loss function and optimizer. So for here we use a model equal to simple nn function, and criterion equal to nn dot cross entropy loss, and the next one is optimizer equal to optim dot atom. Now it will get parameters. The first one is a model dot parameters, so lr equal to 0.001. Now print the model. Now run the code. As you can see, PyTorch offers a different syntax and level of control, making it a favorite for research and experimentation. So in this code, we import our libraries. Torch, which is a core library for deep learning. The second one is torch.nn, which provides a module to build a neural network. And the third one is torch.optim, contains optimization algorithm for training model. Okay, now in the defining the neural network class. So define a custom neural network class inheriting from NN module. And the next one is FC1 equal to NN dot linear bracket 784 and 128. First fully connected layer with 784 inputs and 128 outputs. Now same is the case with the FC2, which is a 128 inputs and 10 outputs, which is the second layer. So in the next we declare a function name with forward. So define the forward pass of the network. Here we use torch.relu, applies a relu activation, and in the next we use a softmax, which convert the final layer output to probabilities. Now after this here we initialize the model, loss function and optimizer. So model equal to simple nn instantiates the neural network, and criterion equal to nn dot cross entropy loss, which loss function for multi-class classification, and the last one is optimizer, which adjusts the weight and minimize loss. So when do you use TensorFlow, and why do you use PyTorch? So TensorFlow is great for production and scalability, while PyTorch is fantastic for research and development. So both framework are powerful. It's your choice, depends on your specific project goals. So, in this episode, we explored the fundamentals of a neural network and learned how to set up basic model using TensorFlow and PyTorch. So, in the next episode, we will dive deeper into training these models and understanding their performance. So, if you want to learn these topics in depth, then leave a comment. I will make a separate playlist on deep learning. So, if you found this video helpful, don't forget to like, comment, and subscribe to stay updated. And as always, happy coding.